Formulas are usually written with one variable isolated, meaning that the value of one quantity is expressed in terms of the value of the other quantity. So for example, if y is equal to 2x plus 1, we say that y is expressed in terms of x. Now, evaluating this formula means choosing a value for x and determining the corresponding value of y. So we can evaluate this formula at, say, x equals 3. If we do this algebraically, this means plugging the value x equals 3 into our formula. So if x is equal to 3, y is equal to 2 times 3 plus 1, which is equal to 6 plus 1, which is equal to 7. So we can say that y is equal to 7 when x is equal to 3. Now, if we have a graph of this relationship, we could have also done this graphically. So we can look for x equals 3 on our x-axis. We look at our graph, and we find the corresponding value of y, which in this case is, again, y is equal to 7. Whether we do this algebraically or graphically, the idea is the same. Now, solving an equation is the opposite process. It involves picking a value for y and determining the corresponding value or values of x. Again, we can do this algebraically, or we can do this graphically. So let's find the value of x when y is equal to 10. Now, this is equivalent to solving the equation 10 is equal to 2x plus 1. So if we plug 10 in for y, then we know that 10 is equal to 2x plus 1, and we can solve for the corresponding value of x. In this case, we know that 9 is equal to 2x, and so x is equal to 9 halves, or x is equal to 4.5. So we can say that when y is equal to 10, x is equal to 4.5. If we have the graph of this relationship, we can use the graph to solve the same problem. If y is equal to 10, then we can look for all points on the graph that have a y value of 10 and look at the corresponding value of x. So if y is equal to 10, we know that the corresponding value of x must be 4.5. Now again, both algebraic and graphical methods yield the same result, and we use the same general reasoning.